Hello. Today we're going to talk about molecular polarity and about polar molecule and non-polar molecule. In order to understand it more clearly, let's imagine we have one electrical cell here. Let's draw it like this, and then we know that the electrons are electrical cell is made of anions and cations. Cations are plus, anions are minus. So let's draw it like that. Plus, minus, 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 and so on. Chemists believe that molecules are made up of charged particles, electrons, and nuclei. A polar molecule is one in which the negative electron charge is not distributed symmetrically among the atoms making up the molecule. But in this first case, we see that negative electrons, are distributed symmetrically. So it means that it's not a polar molecule. It means that it is non-polar molecule, because the definition of polar molecule is a molecule with symmetrical electron distribution is a non-polar molecule. So here vice versa, and the polar molecule is one which negative electron charge is not distributed symmetrically among the atoms making up the molecule. So if we imagine it like that. So the second case is polar case. It means there will be anions and cations randomly moved, not symmetrically, randomly. Here in this first case, we see that anions and the cations are located symmetrically. But in the second case, in this case, we see that plus and the minus are randomly moved, and it is not symmetrically. It is not symmetrically distributed. So Linus Pauling saw the need for theory to explain and predict the observed polarity of some molecular substances. He combined valence bond theory and the bonds energy theory, as well as several empirical measures, to create the concept of an atomic property he called electronegativity. Electronegativity is found to be a periodic property of atoms. Increasing an atom's position on the periodic table is located farther to the right in a row or higher in column. So if we draw here some periodic table, I'll do my best to look it more beautiful. So here we have periodic table. This is our elements around them. So it means the electronegativity of the elements increases if we move top side, and if we move to the right side, and of course if we move to the top side. And Pauling explained the polarity of covalent bond as a difference in electronegativity of the bonded atoms. If the bonded atoms have the same electronegativity, they will attract any shared electrons equally and form a nonpolar covalent bond. We said that the definition of nonpolar covalent bond is molecular with symmetrical electron distribution is a nonpolar molecule. If the atoms have different electronegativities, they will form a polar covalent bond. The greater the electronegativity difference, the more polar the bond will be. For very large electronegativity differences combined with other factors, the difference in attraction may transfer one or more electrons from one atom to other, forming cations and anions. Um, so we should draw some example. So here we have some examples. This chemical bond contains two elements, hydrogen and chloride. According to the periodic table, we see that the electronegativity of hydrogen is 2.2. Chlorine's electronegativity is 3.2. Here we have unequal attraction of the shared electrons, gives one side of the covalent bond a partial charge, negative charge. So here we see that the chlorine is more than hydrogen, and this chlorine will result unequal attraction. So in simple words, chlorine is considered to be not desired people, I would say. So because it's bigger than hydrogen, and it hurts the hydrogen because chlorine, since chlorine has more electronegatives than compared to hydrogen, it results a nuclear attraction of the shared electrons. So we must label with sigma minus sigma for chlorine, whereas hydrogen's sigma will be positive. So in conclusion, if you have any task in the future, like predict the substances to be non-polar or polar, I made this kind of life hack. It's only my opinion. I don't know if it is right or not, but it's my suggestion to use it. For example, methane. If we draw the methane's structural formula, we find out one carbon and 3 hydrogen. And my opinion is like that. If the one element in this case is carbon, is circled by other elements from each side, it will give us a non-polar covalent bond. But in the other case, like carbon dioxide, if we draw its formula, one carbon, 2 oxygen. In this case, we see that carbon is circled only by two sides. Not here we have nothing, here we have nothing, so it gives us polar bond. So by using this kind of technique, you can understand basics of the chemistry. If the one element is circled by from each side, it gives us non-polar covalent bond. As I said before, non-polar covalent bond is a symmetrical distribution of negative electrons. But if one element is circled only by two sides or three sides, but not all of the sides, it of course gives us polar covalent. Thanks for your attention.